Alina Leminen with her talk Spatiotemporal Dynamics of Sentence Processing are distinct neural populations responsible for morphological and morphosyntactic parsing.
Check the microphone, yes, working. So good morning everyone. I decided to just simplify my title, so I'm going to talk about morphology in context and also to complement and maybe to talk about from different perspective, but on a similar issue as Anastasia talked yesterday. And so to start, so we know that language is combinatorial, and many words in many languages are composed of smaller units called morphemes, and I probably don't have to explain to you what that means. But anyways, for instance, many words in many languages are complex in such a way that some parts of them contain meaning of their own. For instance, inflection, it specifies grammatical relations between words. Like cats, I always have cat examples because I have cats and I love them so. And so you see, there's in English, there are cats, and they're also in Finnish. Finnish, which is the language I'm going to talk about, has 14 or 16 different active cases, and also Russian is very morphologically complex. However, inflected words are rarely presented in isolation, and it's often so that adjacent words influence each other, and those elements must agree in, for instance, in number, in a case, in a gender, which is not in Finnish, but in Russian, as you can see. I gave small cats a little bit of food, and I wrote examples in Finnish and Russian. So today I'm going to talk about what happens when we have word level parsing, like kissoille, and what happens when we have adjacent elements like small cats, because they have to agree in case and number. So what happens in the brain when we process these elements. So just to briefly summarize what happens in the brain when we process inflection. So as Anastasia said yesterday also, it typically elicits left frontal temporal network activated especially for regular inflections. But because I'm particularly interested in temporal processing, in addition to spatial processing, I've noticed that electrophysiological processing of regular inflection, such as jumped, has elicited in many languages, such as English and Spanish, and also German particularly, the biphasic left anterior negativity and P600 effects. And they have been suggested to reflect particularly combinatorial processing. It's not always so. Finnish is very regular, and we have also observed N400 effects, which have been suggested to reflect lexical processing, but it's a sort of a debate of what's going on. So that's why we're still continuing studying these issues. On the syntax level, it is also been shown that it elicits particularly left frontotemporal activation for most syntax, and at the ERP or temporal level, it is also elicited often biphasic LAN and P600 effects, especially when these violations or agreement has been on the close or phrasal level in between elements that close to each other. And also in Finnish. And what has been an interesting motivation for the study I'm going to talk about is a recent study by Newman et al. Have noticed that there is a partial activation for inflection and a morphosyntactic word order, so grammar, different sort of parts of grammar elicit somewhat overlapping but differential pattern of activation. So we wanted to see, our goal was to identify the neural mechanisms of word level inflection and also phrase level inflection. And also inflected words and agreement have rarely been manipulated in the same study. That's why it was our aim. So we wanted to see also whether they elicit same neural generators. And seen in frontotemporal networks and the scalp as LAN P600 effects. This was our prediction. And one of the reasons to do this was also we wanted to more carefully localize the observed ERP effects because, for instance, only few studies reported the sources of P600 effects even now, and also there are only a couple of studies which have been able to localize the left anterior negativity. And how we did this? We used frequently used in ERP and MEG research violation paradigm. So this means ryhmävaelteli kuivien. So kuivin is a group rendered of the dry deserts, through the dry deserts. And this is a correct condition. And then we had morphological condition, which is we sort of manipulated stem allomorph and suffix combination. There were different types of those, but they violate sort of morphophonology, and also they should be poikia, but we had such a different combination. This is probably in Finnish the only way of violating word level inflection, because there is no strict regular versus irregular pattern in Finnish, at least to our view. And then, whereas, all the stimuli were of the same structure, it's just the subject had no way of knowing before the target word appeared what happened, whether it's correct or incorrect. And then we had agreement violations, so kuivin was plural, and the aavikko was, for instance, in the singular, and all of the words were inflected too. And then we had a combined violation in order to see what happens when we have both agreement, case agreement, and allomorph violations, so both of them to mix up our subjects. And yeah, here's the English translation. So we had also 50% of plural and singular. Everything was quite balanced and matched. And we wanted to include only syntactic cases, because in previous study there also have been different kinds of cases, semantic also. So we wanted to filter that out. And in order to match correct, incorrect words, we had also fillers. And 16 participants reading simple sentences, and their words presented word by word, and the fourth word was the target always. So here's the procedure, and occasionally judging acceptability. So we wanted to make this task as, even though including violations, but as natural as possible, whereas previous studies have asked to judge acceptability after each sentence. And we recorded EEG and MEG simultaneously to localize our ERP effects. And we use data analysis methods, ERPs, and also we modeled our EEG MEG sources by using S-Loretta with the BESA software, and we used, in addition to normal ANOVA, we used a new way of analyzing ERPs, and also MEG signals source modeling by using permutation test, and we didn't have a priori sort of assumption on where where in our sensors we expect our significances to appear. So you have to always, the downside is that you can also always compare only two conditions, but it's always corrected for multiple comparisons. And what we saw is that for a morphosyntactic condition, even if in sort of normal reading, we see the morphosyntactic, we see the left anterior negativity appearing, even though it's smaller than in studies with normal grammatical or justification. And then we do not see in morphological condition the same effect as for morphosyntax, and combined condition has elicited a larger left anterior negativity. And then I wanted to also show you what it looked like on the central electrodes before going to statistics. And here you also see some kind of activation, larger activation to morphosyntactic, again, condition, but then a larger negativity for morphological condition, and also combined condition elicits again a larger negativity. So what do statistics say? The statistics show that morphosyntactic condition elicited, yes, indeed, left anterior negativity, which was significant, but interestingly also something like N400 effect, which was puzzling at some point, but with a deeper digging into statistics, we show that it seems so there are two clusters of the negativity. So usually the studies have seen only LAN, but we see both LAN and N400, which perhaps shows that because all words were also inflected, so there would be a double sort of activation, a parsing at the word level plus morphosyntactic analysis of adjective and noun, which was interesting to me. Whereas when we had only morphological violation, we do not see exactly the same pattern. And when we have combined, it's like all of the scalp is negative. Yeah, so this was the earlier processing, and then we see the later condition, which is all of the violations have elicited P600, which is interesting. Also, in turn into statistics, they look approximately the same. So it could be that in the later stages the violations are repaired and integrated, as been suggested by many other previous work. However, we wanted to see also where do these effects come from. And from morphological condition, we see that our N400-like negativity comes from, this is the differences between morphological and correct. So for morphological activated, a larger front anterior temporal activation in the right hemisphere, whereas morphosyntax is more left inferior frontal. And it's the activation which is strongest shown in the axis. Whereas in this earlier window, we see that combined condition is something like larger and elicits more significant clusters. So it's not exactly the sum of the two activations, but it's more like a larger network, something additional going on. And interestingly, because we all, in all conditions, we saw P600, so you would expect that they would all elicit the maybe same sources coming, the same mechanism. However, as I'm going to show all the, it's of course it's quite wide spread because it's still a long elastic negativity, but and it's a messy picture somehow, but what we see is that some of them are overlapping, but we see some effects are left lateralized and some effects for some reason are, even though both hemispheres activated, the strongest significance comes from the right hemisphere, whereas morphosyntactic condition elicited again several clusters. So there's a lot of simultaneous, even maybe P600s going on, something that nobody has done before. So it's interesting, even though it looks on the scalp that it's the same type of effect. It seems to come from different parts of the brain coming out simultaneously. So to summarize briefly, I've talked a lot that stem allomorph and suffix mismatch elicited more of a N400 negativity, which was localized in anterior temporal areas, and even though it was bilateral by itself, but as compared to correct condition, it was more on the right. And whereas number and case agreement violation elicited the LAN plus the N400, and it was more prominent in the left frontal areas. And all conditions P600 with a different pattern, perhaps that integration recombination effects with their modulation according to how difficult it is to integrate. And so frontal networks perhaps reflect combinatorial hierarchies in the language. So it seems that, and to some extent, even though in the later time frame there are similar and overlapping, but in the earlier stage they're at least partially governed by the distinct neural mechanisms. So I wanted to thank our group and also BioMag Lab for letting me year after year record the data there. And it's our group in Sibiu in Helsinki, led by Teija Kuela. So thank you for your attention. Please grill me now.
Thanks a lot, and we have plenty of time for questions. In just a second, I'm going to find the microphone.
Hi. Hello.
You're here.
Yeah. Thanks for an interesting talk. It shows again how important it is to look at the temporal resolution of these events, and just to show the differentiation between the processes, which are on average, a temporal average scale would not be visible. I have a question about, first of all, can I clarify when did you time lock the analysis to?
Yeah, this was a visual study, so we time locked to the onset of the target word.
So the onset of the second word?
Yeah.
So not the word with the violation itself?
Oh, not the word with violation, yeah, because, yeah, always the violation word or non-violation or combined, yeah.
Yeah. Did you look at inside the violation word itself? Sort of time locking it on to the onset of the suffix.
That would have been nice, but if we had auditory.
Yeah.
Yeah, that's interesting sort of an idea, or how would you do that? I would like to know, maybe somebody would tell. Except if you time lock or record eye tracking.
Yeah, that's what I was thinking.
That's something, yeah, that's something we're currently doing, but not that
Yeah, so you presented words kind of in a line. They appeared one by one, or they flashed?
They flashed word by word, which is a standard procedure that happened.
Yeah.
So the subject had no way of knowing before the target, sort of the violated word appeared. The context was always the same for. Yeah, so only when the violation came, he or she knew whether it was violated in accordance with the previous context or whether there was a stem plus allomorph. So before that, it was always exactly right, everything, nothing's special about that than something.
Yes, it's kind of a retrospective analysis rather than prediction violation. So, and you know you have the triggers. If you had the triggers for the violated word, no, I understand it makes sense. It's a violation only in the, okay, the eye tracking would have probably been an interesting way of looking at it.
It's a very complex analysis still, but that's something, a tool to consider if you have a possibility. But if this was an auditory study, which I have done plenty, I would expect because even though here we saw N for 100, but we've seen in auditory study also the big N for 100, but when we time locked the onset of the suffix, we saw a small LAM there too. So maybe it's in the morphological condition also hidden by the huge access and semantic negativity. So that's something maybe to for a future study too, or something that you do in the auditory. So it's nice to.
Yeah, it's very interesting. So I have another little question. How do you? So what do you think about your later effects of the P600? The similarity of those between the two conditions that you've shown.
Yeah, there was a similarity, but also differences on the hemispheres.
On the hemispheres, yes. Well, what do you think about that? I'd like to know.
I think the pieces, my speculation is because it's, in the earpiece, it's such huge and long-lasting way, so it would be nice to, somebody has done it probably, I think it's in the Spanish group, but not in the source level of, they have separated the speculation is also about N for 100. They're composed of several different sub-components. Okay. So I would think that it would be nice to somehow try to manipulate and take it to the smaller slices and to see, because it's a large network of areas activated at the same time. So probably there's a lot of processes going on, and maybe if you have sort of a violation like morphosyntax, you have to integrate more, and especially in a combined condition where like half of the head was. And of course these are averaged sources on the standard brain. So, yeah, this is very interesting. So last one, I promise. So the effects of the morphological violations, right? So with the syntactic effects, it's easy for me to kind of think about it, because you would expect a certain class of word after the suffix, right? Yeah. So if you can please go back to your examples, because I don't speak Finnish very, unfortunately. Yeah, but I can
it's hard
try
for me to pass. That's it. So for the syntactic conditions, the agreement violation, right? It's kind of easy to know what you're expecting. So in a way, you have an expectation violation because you expect a word of a certain class, right? So, but for the morphological violation, I would have thought that all the effects that you would see to do with morphophonology, you would see time locked to the onset of the suffix and not to the onset of the second word. So how do you disassociate between the effects of kind of retrieval, because you don't really, as far as I understand, you don't really look at the morphology in this case. You
mean what kind of violation or what kind of process here in morpho?
So if you time lock all of your analysis to the second word, right? The morphological or morphophonological violation wouldn't be on the onset of the second word. It would be present. The processing of this violation would be present inside the first word, right?
You mean like this?
Maybe, yeah.
So you would kind of already have an expectation of what's going on. I'm not sure if that grasp.
No, it's just that when you time lock to the second word, the lapi, right? That you time lock to Lappi. Oh.
To this one. Oh, no, not to Lappi. To Aavikko.
Okay, then it makes sense. Sorry. Yeah.
This one.
Okay.
Yeah.
Okay, so you
maybe,
did time lock there. Okay, sorry.
to the
Then.
target word, yeah.
Yeah. Okay.
Yeah,
So
maybe.
that makes sense. I just thought you time locked to the second one, looking to the effects of the first
I
one.
thought he meant the second word. It's like huiva is the first word, and I thought.
Right.
Yeah.
Now it makes
Always
sense.
on the target word. Yeah.
Yes. Okay. Thank you. Yeah.
So I hope that clarifies. So. Yeah, and we can discuss more. Oh, any other? There were a lot. Questions. Good questions. Oh, Kira.
I just have a comprehension check question about different localization of your N400 for suffix violations and agreement violations. So what is the underlying story, you think? Suffix violation leads to lexical access problems.
I think, I mean, Minna Lehtonen has also been doing a lot of visual studies and with correctly inflected words, and they have always, and with MEG and EG, and we have done that also, we have usually seen N400.
Where? My question is localization in this case. N400, yes, of course, but you mentioned two different sources of N100 depending on whether it was a violation in agreement or in stem allomorphy. That's what I'm interested in.
This is what we meant.
Mm-hmm.
N400 is an anterior temporal, right anterior temporal area.
Right.
Yeah.
So let me try to repeat again. In your conclusions, or at some point, you said that you have identified N400 for suffix violations and for agreement violations, but the sources were different.
Yeah, the sources were, yeah, now I see. The sources, I think, maybe what I have thought that the agreement violations such may be salient and big, so it's as compared to correct conditions. So this must be, because there were two effects, and the lung and N400, which we only saw on the scalp. So maybe it's less salient in the, and it's just bigger in the sources. So
That's why one was on the left and the other on the right?
maybe, but as you see, this is just what Loretta tells us.
Okay,
Yeah.
thank you.
It would have been nice to see both, but sorry.
Then we can move to the next talk. And